And we're back live, are we? Yes, okay. Lovely. Welcome to part 2 of today. Oh, I've just realised I haven't even called it part 2, have I? Never mind. Doesn't matter. It's a continuation anyway. Here we go. I just hope it'll do it as a separate name. I honestly don't know how it's going to record this or what name it's going to give it. Never mind. It's Twitch. It's happy. And I've got a shader. Yeah, there we go. Shader's now working, and we now have a shader operating on this well, we haven't actually, because I haven't even initialized it. We haven't said to use it, so that's fine. We've got a shader though. Ooh, look, program 1. Do that, and it closes properly, which is good. What did I do? What did I do to make it work? Well, let's have a look at texture vert. Let's change vec4 to a vec3, which means this has to be a vec3. There we go. Doesn't matter. Doesn't matter. Okay, well, we'll try that. Fragment shader was just a semicolon missing there. It was easy to spot. Okay, let's see if we've got any difficulties with our texture shader. So let's go down to our main and let's test our other shader. And how do we do that? You may ask. Let's do one of them. Pop it in the here. Can bring you back one actually. There we go. This is going to be program. Oh, let's be original 2, and let's not call it amber color. Let's call it amber texture, because he's going to do textures. We can now do another SDL log. Copy and paste. For program 2, we're going to use shader program 2. And here we just have to delete. Copy and paste. Should do in the reverse order really, but it doesn't matter. 2. Yeah. And yeah. And that should do it. Let's try that. There we go. And there you go. So program 1 and program 2. All ready and waiting to be used. Oh, that's nice. So we have that part. We have shaders. Excellent. What else do we need? Well, there is that little small thing about models, isn't there? Yeah, there is. There is that. So I think we can get rid of all of this code now, can't we? Where should we put it? Where should we put all of this code? Got tons of it. We could split it down into file, handling, and shaders, couldn't we? Amber 3D. What do we got so far here? Core, display, and object data. That's a structure. That's a good point. That's a structure. And it's in a header file. And that's a struct. Just wondering now whether I can make that into a CPP. We could, in fact, do that. It's got nothing in it. Not really. I don't really want to make that into a CPP file now. I don't want it to be compiled. As for this stuff, I don't care whether it gets compiled or not. This lot would need to be in CPP files. That's a bit of an ugger. I'll keep it here then. Until I'm decided, I'll just keep it here. So, what we've done so far, build shaders, GFX card, store the handle, shader program 1, shader program 2, and gives us, and there will be 2 programs stored on the GFX card. 2 programs. We've got them, yeah. We now need something to use them. So that's your shaders. We'll just do that. And I'll call this shaders. And do that. There we go. That's our little shader base. And this is deletions, isn't it? So shut down. Shut down stuff. Okay, I'm happy. As long as I've got the deletions in, I'm happy. We make them, we delete them. That's good. That's very good. We should really make this into a class that is able to delete these shaders properly. But I'm not going to. Because it's not really worth it at this stage. Put space there. Actually, we'll put a couple of spaces there. Get this while loop, obviously, in the middle. Yeah. So, who knows how to load, convert it to OpenGL, send the data, GFX code, start up a basic renderer. Okay. So let's do a cut and a paste. And we need to load up the model. Okay, I think we can do that. Sure, we can do that. Let's see have we got a good way of doing it? As a prototype, there's an easy way. Just wondering how long this file's going to go to. If I do it as a prototype, it's going to be about 1,000 lines long, isn't it? Yeah, that's fair enough, I don't care. What I'm thinking is, why don't we start... Well, we've got the shaders. So we need 2 renderers. One for textured items and one for items with colour only. That's what I'm thinking. Have I got any renderers? I'm clicking around here trying to find out if I've got any simple renderers. OpenGL. dear. I don't think I've got any. Interesting. Okay, I wouldn't put a renderer in here, would I? No. Why wouldn't I put a renderer in here? That was bloody stupid of me. Let's have a look inside this file. Oh, yes, I think we may have a renderer. Well, we haven't. Oh, wow. Yeah, this is funny as hell. Okay, how are we rendering here? This is looking rubbish. I see. Yeah, I see what I've been messing about. Yeah, I want to play with this idea. Problem is, I don't want to limit the models within our game. Now, what I'm going to try and say here is completely stupid. What I want people to be able to do with our game is to place their own models in it. Why? Because I'm a rubbish 3D model artist. I admit it. It is a failing of mine. I've tried and tried and tried, and I'm not joking, I'm rubbish. I actually got a human-like form, but I didn't animate it, did I? But I did actually get to the skeleton. I did put a skeleton in it and nearly get to the animation stage, and luckily I was never employed to do animation, so I'm one of the lucky ones. But when it comes down to 3D models, I suppose I can. I know how to do it, and all the formalities behind it. But could I actually do it? Let's have a cup of coffee and think. Because we're now at the stage, where do we start from here? We've got a shader. So we actually know the information that we need, and we can list that information, and we also know how our object and the information that we've got available is all here as well in object data obj, because that is a couple of files that I've already done, which I've just laid in here. Obj structure, I'll go through it slowly from the top. Okay, so we have a structure for vertex, a structure for texture coordinates, and you can see that's the notes from the wiki page. This is literally the wiki page copied, copy and paste, and then as it says something, I've just put struct in. So I've got struct for vertex normals. I'm going through this slowly on purpose in case people want to pause the video and take these for themselves. Vertex parameters I've added, and it tells you what they are. And there's a load of stuff about face elements, how they can be represented. So I've represented face elements. We'll do this in a couple of bits. So the first type of face element is that one. And the second type of face element I'm interested in is that one, which we don't need. Because anybody who can understand what I've written here knows that that's a quad, and we're not going to be using quads. So this part isn't actually needed. All you need is that struct there, face element up to there, and then it didn't even, yeah, right, okay, so I haven't done anything else with it. That's for quads. This is the one we're going to use. This is triangles. You can tell because it's all in 3s, and that one's all in 4s. That's how you tell. After that, in the wiki, it went on to line element. So you can draw lines. Then the material file names, obviously, for the materials that we're using, or not, in our case. The use material is actually a thing, so we have to detect it. Object name, it sometimes decides to name an object. That's fine. It's usually the title. Where's our OBJ, our model? Object name is usually like material libraries there. Object name is Suzanne, because that's the one we're using. Oh, went back to the wrong place. That was clever of me. Object name. Will you stop it with this marketplace rubbish, Microsoft? Group name, in case it's in a group, you can do that. Smooth shading, I don't know, that's a string. Yeah. But it says S1 and S off. So I think it's on or off. So if you detect that one, you can probably detect on or off or something, I don't know. Then we come to the MTL file, which is the second one, Bob MTL, which is a material file. This is a material template library, MTL. And it goes through material names, the colors, which is ambient, which I described in shaders, diffuse, which I described in the fragment shader, specular, which I described in the fragment shader. Specular highlight components and emissive coefficients. Interesting ideas. This is not a colour I've put next to it. Even though it says red, green, blue, it's not a colour. It's a component, which means that they will probably be used as percentages. Just out of interest. So I think those are percentages. Don't know, it doesn't tell you. Emissive coefficient is how much you emit. Amount of light emitted, yeah. The amount of light emitted by an object, like a light bulb, for instance, or a torch, or a campfire, or an item of magical means, I don't know. Refraction index means it's clear to being solid. But glass has a refraction index. If you want to know what a refraction index is for a solid material, look it up under physics and you can get a full refraction index of every single material going. If you can't see through a material, it doesn't have a refraction index. It just goes off the Phong lighting. But it is an interesting statistic that you can find in these OBJ files. Whether something's transparent or not, transparency. Multiple illumination models are available per material. There are enumerated as follows. I've left that in. So illuminations for colour on and ambient on, highlight on, reflection on. You can use the illumination factor normally with 2. I think it comes through normally as 2. 3 is ray tracing, which we're not doing. Transparency glass, we're not doing. This basically tells us which type of shader to use. That's what that tells us. Texture maps, you've got ambient, diffuse and specular for texture maps, so you can texture. I would call those bump maps, but it says texture maps. Alright, we can define separate maps to be used through our texture layers. Okay, so we can have three textures going in, so you have sampler 2D 1, sampler 2D 2, 3 and whatever. Alpha texture map, the bump map, which is famous for making bumps. That's actually a blooming useful technique for making stuff look good. It's very cheap, it's just one file, that's a file name, and that file name has a bump map in it. Very simple technique, very good to use. Right, displacement maps, that's up and down, that's what we're going to be using for our maps. Literally, our terrain. We'll be using displacement maps. Stencil map, so you can stencil over things. So I don't know how, I don't use stencils very often. And then there's a load of random crap at the bottom. So I've talked about the object data structure. That's good, and that's where I've got all of these from. Okay, I was going to leave them inside the object data structure, but then decided to pull them all out and list everything I've got in there. And I do have uniform vec3, you light, colour, shine, dampen, reflectivity, still outstanding. That one is user defined. Shine, dampen, reflectivity. Shine, dampen, and reflectivity. I don't think I'm using them here. I think these are user defined, you know. Damn it. I think we should be using these. Let's just have a look at our material a minute. Eloom 2, N, I and D. That's your emissive. That's your normal alpha diffuse specular. So I've got KE, which I think is emissive, NI, I remember this one, and D. I think those are the numbers that we're after. To the power of 1.45 doesn't sound right. Let me just put that in here a minute. Map bump. So let's just go back up. Texture maps. Illuminations. That's that one there. That's 2. So highlight on. It's great, isn't it? D and an I. I think there's D is transparency. So a 1 means 100% not transparent. Transparency is really opacity. No, it's not, it's transparency. So 100%, no. Opacity 100%, no. Oh, godfathers, who cares? But 1 means it's 100% not transparent. Ni is a refraction index. A value of 1 will cause no refraction. but we've got 0.45 on it. That's light scattering. Okay. So that is that one. That's Ni, if we want it. And D is transparency, which is this one here that we've already got. So we've got D, we've got Ni. E I seem to be ignoring. Emissive, yeah, I thought it was. So that's E, Ke. So I've got Ke, Ni and D, that's these three here. And I'm looking for a shine damper and a reflectivity. I'm thinking that Ke is 0, 0, 0. No. In other words, it's not emitting anything. Because we're not doing lights yet. They complicate things. Refraction index. Well, the emissive coefficient we could use really is reflectivity, but I don't want to. We don't seem to have reflectivity. And I'm thinking we could use Ni as our shine damper. I don't want to introduce a diffuse map. Or oh no, I'm going to be using that as the oh, it's the map KD. Yes, I do want to use that one. Sorry. That is your texture file name. For now then, because I can't really decide. Just realised these have got semicolon. Oh god, I've just pressed the wrong button. Just realised these have got semicolons on. Can I take them off, please? Not commands. We're just going to put user defined on these. So in other words, we have to provide them. Which is a damn shame. Light colour I can understand, but shine damper and reflectivity? Okay. Fair enough. We'll go with that. Right, so we've just had a good chat about what data we have in our OBJ file by accident, which is interesting. You need to know what your data is, so that's why I read the wiki and then copied it out and did all of this rubbish. So thanks, Bob. And thanks, you. What am I gonna do? I wanted to make a warehouse type idea where the user could place in their own models for the world. So they, a bit like on the Matrix idea, where as you enter the Matrix you go into this room and then all these big things like shelving units come racing down in front of you, and you can pick whatever you want off them, or you know, change models or whatever. I'll just have a room full of stands with models turning around on them, and you can go and change and you know, load up different models to different plinths, and that will alter your world. You know, you can number your models 1 to 10, say, and go out into the world and say, spawn model 1 here. Simple as that for spawning things. And then you would have a set of construction models, like walls, doors, ceilings, floors. Floors are ceilings, usually. Roofs, maybe. You don't need roofs. There are no roofs on a castle. Yeah, anyway. So that's the idea, is just to have like a warehouse that the player can walk into and change whatever models are in his world. And that means on his web page, basically, because that's what he's going to get, control over his own web page. If he goes to look at a server somewhere else, well, he will be looking at either their web page or a central server. If it's a central server, it's probably got a full world on it that you can play in. If it's somebody else's machine, then it will have their web page on it in 3D, which could be anything they've designed. So, yeah. To start off with, let's do the minimum requirement to put our Bob on the screen. What would that entail? Well, we've got a window. Right, if we've got a window, we're alright. We might need some kind of clean-up to this. I think we're going to put it out here. In amber. So then I can structure possibly some of it better. So, this is going to be... let's start splitting this area off, shall we? I'll give it a space. Let's go for loading a 3D model. Let's do that next. I think that's the easiest way of doing it because it is actually easy. It's not rocket science. At the bottom of it, I'm going to keep a cleanup, and it's just going to be a void cleanup, because I don't know what I'm going to need for this. Yeah, that'll do. So I'm going to keep you handy, just in case I need... Well, I do need you. Are we going to call it a warehouse or not? Let's call it 3D storage. 3D model store. Okay. Uh, 3D model store. That's usually what I do. No idea how I'm going to... what's wrong with cleanup now? Oh, it's because I've got return in. Yeah. Return... false. Because we haven't done it. We can't return true because we haven't actually programmed it. What kind of things we're going to need? We need a window. We've got one. We need shaders. We've got them. We need model locations. We can make them up. Right, how do we want to store a model location? Well, really, we should store it within the model. Should we not? Should we not have a model? I think we should, but we need all the information for it. Alright, forget this. No, this is not gonna happen. Not gonna happen like that anyway. I am absolutely drenched with this heat. Yuck. Need a towel. 1 second, I need a towel. I'm just absolutely getting drenched with the heat. That's awful. Icky, sticky heat. Yuck. Just dry my hands. Let's have a look. We will have a model. Everybody calls them entities, don't they? Well, that means everybody thinks that we're going to do like entity special systems and stuff. Well, we're not. We're going to do blade systems which work, not idiot ones. So we'll have a struct. What we'll call model. Why not? That's better. Grab me coffee. What should we put in here? We'll give it an ID. Okay. Well, OpenGL is going to do that for us, isn't it? Now, I don't know if you know what a VAO is, but during loading a 3D model, you're certainly going to learn. It's a vertex array object. It's an array of pointers, 2 buffers. And that is given by the graphics card. That's good news. So we'll keep that. To go with that, we also need to keep an index count because we're going to use element arrays. So we better keep that as well. Those two go together. So that's going to be the index count. We'll need those two, otherwise things won't work. We can hold the hold on a minute, we could actually hold the program as well. I'm just trying to think. Is it we could actually shader type, shader number, shader handle. I think we will have bool has texture, because that's useful, equals false, because it doesn't automatically have a texture, and that means we can have a uint for like a VAO ID and the program ID that we've had for these shaders. The graphics card will also give us a texture ID if we have it. And of course, 0 means there isn't one. So we can actually number that. So that can check, and because of that, we can then tell which program we need for shaders. Oh, so we don't need to store the shader. Okay. And that's all we need. Yeah. The only thing we need to come out of all of this is this model. The only things that we need to actually put the model on the screen is that information there, plus that information there. Interesting. Is that correct? Let's find out. Let's start by trying to load the entity. Okay, model. So, there's your model. We'll call it load model, I suppose. And what we'll need is a const standard string, and that will be and name. I don't want any more than that, just the name, so it's going to be Bob. Because it's funnier if I do it that way. That's the only reason I'm going to do it that way. Because it's funnier. Okay. So we've got two structs above us to help us out. By it, we're going to need them. Okay. Let's start with the obvious. We will start by making a model. Okay. There you go. Do we need to star that? No, because it's holding three uints and a bool. So we can have that in memory. Doesn't matter. Okay, so we're happy with that. It will die if we're not careful. We'll be passing it back out, so it doesn't matter. Okay, I'm happy. So, we've got our model. What do we want to do? Well, we want to start deciding what kind of information we want to read from our files. Because we've got two files, bob.obj, bob.mtl. So let's start setting these up. I'm going to make a big block of them, because there's a big block of them. And they're all going to be vectors. And what we're going to make is an array without an end. So we can just keep storing more and more and more in it. So arrays have a definite size. Now this vector creates an array of indefinite size. And that means it can have a lot of stuff in it. So we better star it up, otherwise we could run out of memory. Especially if we've got a lot of models. Okay. Unsigned. Oh, what am I doing? Uint star. And this can hold our index. This is going to be our index array. So I'm going to say that it's an array so that I know that that's how I'm going to treat it. I'm going to treat it as index array, and then it's going to be 0, 1, 2, 3, etc. Okay? So that should work if we keep putting indexes into it. What else can we have? Positions, normals, colours, textures. Okay. The kind of things that we want to pass into our shader. So I'll make another vector, and it'll be a float star, and we'll have a few of these. About 4 should do to start off with, I think. We'll have positions. That's the position for each vertex. We can have normals. Yeah, we can do that. Hold on a minute, I'm pluralizing. Okay, we'll pluralize. Otherwise, if I don't keep pluralizing and I don't keep it the same, I'll get myself confused. Normals, colours. So colours array, and textures. I think was the last one, wasn't it? Yeah. Textures array. So all of those. Index isn't pluralized. There you go. Indices array. Pluralized. Now everything's pluralized. We're going to have to pull data in. And we're going to have to create a file name. Okay. So let's have a standard string data buffer. That's just for holding information. And standard string file. I've got name, I want file path. Equals dot slash, no, doesn't equal that. Equals dot slash, where we put it, model 3D. Okay, model 3D slash Bob plus name, and then it's going to be plus dot obj. Alright, we'll have that. Okay. So we've got a data buffer, we've got a file path. We're doing good already. We're also going to need something to use with that split string, aren't we? We're going to need that to split down the data into its component form so we can store them. So let's make one of those. I'll make that here, because it's part of the buffering stuff. So we'll have a standard vector, I think it was, that used. Vector. Standard string. There wasn't any new going on in that one. I'm worried now. Have we outdone ourselves here? I don't know. Will that work? If we split that, it's all on that pushback. And that catches the last one. And it's all within memory. Does it get deleted straight away? We'll have to delete that memory after using it. If we don't, we're going to run out of memory. Alright. Okay, as long as we know. Delete after use, as we may run out of memory. This is all on the stack. Okay, so we know about this problem already. Is it something we can fix in the future? Yeah, we could send it all out to the memory out there in the heap without any problems. We just put star there. Which I might do now. Have we used split string for anything else? No. Just testing and messing around. Okay. Well, that's what you get. Split string, come here. You're getting one of them. And text line. Hold on a minute. And text line. So we're only splitting each one by line. And then it's going to go around and split the next one by line and split the next one by line. No, it's not worth doing. My bad. That's not going to ruin the heap. We're only using it for short spurts. We're good. We're good. We don't need that. Get off. Stop messing me about, Microsoft. Oh, yeah, keep messing me about. You do that anyway. So we've got a data buffer, we've got a split data, we've got a file path, we've checked everything out, memory's okay. Okay, index size. How many items of data? Okay, I'm going to put this in. We'll see how it works out. We'll have a uint index size. It just saves us from having to repeatedly find the size of, I guess. So I think I'm going to include that. I think I've got quite a lot of stuff there. if I'm going to be honest. Alright. This is going to be interesting because I'm really got to take the headphones off, but never mind. Hurting like hell. There we go. This is with headphones off, so if my voice fades out and you can hardly hear me, I apologise. It's a very specific mic, and how you use it depends on the quality of the recording. You see what I mean? uint, index size. Right, let's load the vertex positions. That's positions array, isn't it? Let's see what we can do with that. Load vertex positions. So that's what we're going to do next, I hope. Okay. So we'll take our data buffer, which is a string. Good. Data buffer. Come here. And that is going to be equal to where have I put this? Yes, we're alright. Okay, so it's read text, isn't it? Star. No, a data buffer isn't. Our data buffer has to be starred. Okay. Standard string data buffer. Are we allowed to do this? Are we allowed to do this? No, we're not. This is going to do line by line. Okay. We're going to have to send a vector of... we're going to have a vector of strings out of this. Okay. Vector of string stars. So our data buffer's wrong. That's a vector of string stars. Vector of std colon string star. There you go. That's all it is. Yeah. That's going to be fun. So now data buffer can equal read. Yeah, read text file. And what does it want? Oh, the file. I think we can do that. File path. Alright, that gives us the text file. Magic. So we can use the data buffer now. So the index size is going to be how much data are we dealing with? It's going to be data buffer dot size. That's how much data we have. Oh god. I'm not sure how to do this. Right, okay. So what we can do now is a for loop. Okay. Let's start the for loops. For, uint, and it's count, as usual. I use count, don't know why, equals 0, as long as count is less than index size. Semicolon count. I don't even know why we need index size, but we'll see. We'll see if it comes in useful. Normally I won't put one in, but dripping. Oh, the heat! The heat! Actually, what are we on now? 59, yeah. Liquids. Hiya, viewers. I've got the last of my coffee. I've had my ice cream, but I'm still melting. We did have to pause for that, but hey-ho. I've got black burpy bubbly liquid to help me out. We'll try and keep going for a bit longer. But I am starting to... Blade, he's starting to frazzle. Yes, I'm starting to frazzle in the heat. It's slowing me down immensely because I'm now totally unsure of what my brain's trying to make out of what I see on screen. I've got words in front of me which don't mean anything. Alright, from this we can get our index array. That's a definite. What are we counting though? That's not right. Hold on a minute, something really, really weird going on here. What I'm thinking is wrong. That's what's going on here. You see, we're nearly right with what I've done, but it's wrong. It just doesn't look right to me. So I think what I'm going to do instead of making a right hash of this is go away, have a well, can't have a shower because, yeah, try and cool off, and we'll pick this up tomorrow with the load model business, because I'm not happy with what I'm seeing there. There's at least one, maybe two too many variables. Yeah, and it's... And I've also ignored the fact that we need... back up at the top here. User-defined shine, dampen, and it floats. So we do need these two as well. I've completely ignored them. So we can cut those out of there now. What we can do is we can paste those into our model here. Okay. And it's from float, isn't it? Whoa! Hey, boy, slow down. Try that again. That's better. Here we go. I need a couple more things from that. That shine, damper and reflectivity act in specific ways, so I can do that now. I know what this is about, and it's hidden from us, usually. And it's never explained by anybody how this works. Yeah. It'll be in the fragment one here. So, shine damper. Where was the power one? One of these is to the power of, here it is. And that's the shine damper is a power of 2. So I need to know that. I usually use about 8. It's 2, 4, 8, 16, 32, 64, you know, that kind of thing. I think if you're a programmer, you know what that sequence means. And reflectivity is a percentage. 0 to 1%, isn't it? Let's just check. Where have we got it? We haven't got it down the bottom. It's there. Yeah, it's a percentage. Okay. And this is a percentage. And that is 0 to 1. 0.00. 0.00 to 1%. Yeah, that's it. That'll do nicely. F for float. Lovely. Thank you for that. Right, so I know what those are now. That's good. I can usually remember them, but if I can also get them the wrong way round, so I won't do that this time anyway. But I'm sorry to say I'm going to cut this short. I'm melting. The temperature in this room is so high, it's untrue. I'm surprised my computer's working. It's convection cooled. So God knows how the chip's being cooled right now. Yeah, the desk is getting pretty warm above it. Bloody hell. So yeah, I'm going to shut down, well, not just take a break, but go melt in a corner and catch you tomorrow. In the meantime, keep coding, keep exploring. Blooming heck, peeps, in this weather, you better be having fun.